Okay, two problems here. The first both have to do with what's called distance traveled. So the idea is that you have a particle on some sort of moving system. You can simplify this just to be a particle on the x-axis, and maybe it's going right, and then it bounces left, and maybe it goes right. And I'll share this little story. We have a small little like toy ball that has a motor inside that is supposed to randomize its movement so the ball can kind of move all over the place kind of haphazardly depending. We have it for the cats, and they sometimes are entertained by it because the ball, you never know where the ball is going to go. But this question postulates what is the distance, the total distance traveled. So this is difference. This is a difference from what's called displacement, where it's not a change in position. For instance, typically in a 5K race on the Brebeuf course, if I'm starting here and then I'm running all over the place and then I'm coming right back to my starting point, my displacement is zero because I'm starting and ending at the same place. But clearly, the distance traveled is not zero. This says if you roll a ball to someone who is 5 feet away from you and then that person rolls the ball back, the change in position is zero, and yet the distance traveled is 10 feet. However, there'll be provided there is no change in direction, the change in position is the distance traveled. So really, we have to consider changes in direction. And where changes in direction occur are places where the velocity is equal to zero. And as you saw from the previous days, velocity is equal to the derivative of position. Therefore, to find the distance traveled on a time interval, we're going to use both velocity to figure out at what point the object changes direction, and we're going to use the position function to determine where that object actually is at the points that it changes direction. So two problems. Number one, find the distance traveled by an object moving along the x-axis between t equals 2 and t equals 5 seconds if its position is given by this function s of t is equal to t squared plus 3 over t minus 1. And s is measured in feet and t is measured in seconds. So to start, as you might imagine, we need to do t prime of s prime of t, which I'm going to call s prime of t is equal to v of t to solidify that in your heads that this is a velocity function. And we're going to do quotient rule. Low, d high, minus high, d low of t minus 1 is 1, over low, low. You will want to simplify this because we're trying to set this equal to 0. So 2t squared minus 2t minus t squared minus 3 over t minus 1 quantity squared gives me 1t squared minus 2t minus 3 over t minus 1 squared, or t minus 3 times t plus 1 over t minus 1 squared. So this is the velocity function, and this is equal to 0 anytime that t equals 3 or t equals negative 1. And we will, for the purposes of what we've been doing, call those critical values. I'm just going to do a sign test on everything. So we're going to list all critical values, including the domain restriction of 1. Let's put a chart here. And, well, actually, that chart, some of you have been asking questions on these chats about domain restrictions. And this domain restriction is between t equals 2 and t equals 5 seconds. So I'm only going to put those values down, because really your sign test should only be listed for the domain that's defined. So this means we only have a critical value of 3. And if I plug in, let's just be careful and plug in a number like 4, I'm going to get positive, positive, positive. And if I plug in a number like 2.5, I'm going to get a negative for my sign test. So this means that it's going from smallest to biggest, which means that t equals 3 is a minimum. But really, at some point, we don't really care whether it's a min or max. We just want to know that it changed directions at t equals 3. So my next point is to figure out what is the position at these values. These are my 3 points that I really want to know. What is s of 2, what is s of 3, and what is s of 5? And that means plugging it back into the original function right here. S of 2 is equal to 2 squared plus 3, that's 7. S of 3 would be 12 over 2, or 6. And then S of 5 would be 25, 28 over 4, it's also 7. Your next bit is to discuss the difference. Okay, so this particle went from 7 to 6 and then back to 7. So the difference between 7 and 6 is 1. And I'm going to put that in absolute value because the difference between 6 and 7 in an absolute value is also 1. It traveled 1 to the left and then 1 to the right. So still in this day and age, even with coronavirus, 1 plus 1 is still 2. This means that its total distance traveled was 2 feet. So that's a simple example. The question I could also ask is, what is its displacement? And its displacement is, well, if it started at 7 and it changed at 7, its displacement would be defined as just a s of 5 minus s of 2, and that would be 7 minus 7, or 0 feet. So keep in mind the difference between displacement and distance traveled. Distance traveled is very much an absolute value. Okay, moving on. Second question, same idea. First 10 seconds, so we're going from t equals 0 to t equals 10. Just a different function. This is more polynomial, so we're going to do a first derivative. V of t is equal to t squared minus 5t plus 4. It's a lot easier to take a derivative of, and that means that this factors into t minus 4, t minus 1, and really no domain restrictions, just two critical values. My critical values are 1 and 4, and if I do a sign test on the domain restriction from 0 to 10, I'm going to get, let's put 1 and 4 down. I'm going to get a positive, then a negative, then a positive. So it is changing directions at each of those points. I can very much use those as critical values. And let's now figure out what's s of 0, s of 1, s of 4, and s of 10. And you can decide, okay, clearly plugging 0 in is pretty easy. We get -3. Plugging in 1 is not so easy. Plugging in 1 is going to be 1/3 minus 5/4 plus 4 minus 3. And I'm going to cheat ahead. You can calculator this out. That's going to equal to -7/6. S of 4, I'm also going to cheat on this one. You're going to have to plug that in. Or you can use regular or synthetic, and it's going to be about the same, but you'll end up with -17/3. And S of 10, when you plug that in, you're going to end up with 361/3. Your next step, now that you have something that's a little bit harder to visualize, is you need to figure out what the differences of each of these are as an absolute value, meaning what's the distance between -3 and -7/6. Well, the operation to do would just be -3 minus -7/6 in an absolute value. We're only concerned with what the distance traveled is, and that simplifies to 11/6. Then we're going to do the difference between -7/6 and -17/3. As an absolute value distance, that is 9/2. Then we're going to do the absolute value difference between -17/3 and positive 361/3. Again, in absolute value, the difference in distances is 389/3. So this means that from time equals 0 to time equals 1, this is how far it traveled. Then to go from time equals 1 to time equals 4, it traveled that much, and then it changed direction again and traveled that much. So the sum of each of these, 11/6 plus 9/2 plus 389/3 is the total distance traveled. Add them up, 815/6. You would be allowed to use a calculator on this. I'm not trying to test your ability with heavy fraction use, at least by hand. So that's the total distance traveled. The units would be in feet, and I think so by the problem. Yeah. Okay. Unlike most times, your homework is actually printed at the bottom of this. We made it very simple and put functions. The answer key is right next to it. So there is no separate homework sheet. Just follow along with that. See you later.